Okay, so basically design for test. In design for test, you design the chip to increase observability and controllability. So observability is actually being able to observe the output when there is any observe change in the output when there is faults, and controllability is actually to control the specific input of the chip. Alright, if each register could be observed and controlled, then the test problem reduces to testing combinational logic between registers. Okay, so you can control the logic blocks to make it enter a test mode where they generate the appropriate test patterns and report the results automatically. So one of the examples is actually to have a scan path, right? In the scan path, you are actually putting additional scan register to the chip. Okay, so here in this case, you have a logic cloud, and this logic cloud is put in between two flip-flops. So for example, in your circuit, you have a logic cloud. What is a logic cloud? A logic cloud can be any circuit inside. It can be a multiplexer, it can be a NAND gate, it can be a NOR gate, it can be an adder, or a multiplier, anything, right? And this logic cloud is a combinational logic here, and you connect it to a flip-flop. A flip-flop from the input to the flip-flop from the output. So this is the in and this is the out, right? So this flip-flop is controlled by a clock. Okay, so at the rising edge of the clock, if the clock is positive edge triggered, so this is the clock. Right, the clock, right, and you have your input data, for example like this, right, and here at the node 1, this is your input. So at the node 1, it will check and the input will be clocked. So at every clock edge, it will check. So here it will go 1 and 0, and it will go high and until the next. Okay, so this means this flip-flop helps to clock your circuit and help to control when the input enters the logic cloud. When it goes into the logic cloud, it will go in, it will come out, and there will be a slight delay, and at the next rising edge, it will. So for example, the output of your logic cloud is like this. This is node number 2 here. So then it will be clocked again. So it will go look at this clock and come out again. Okay, this is 0 and this is high. Okay, so this will be your output. So your flip-flop actually helps to control the timing of when the inputs or to go into the combinational logic, right? So for example, if you are imagining if there are many inputs here into the combinational clock, you can imagine that all these are all data which are racing to go inside the combinational logic clock. And you want, if the person is in a race, they should all start at the same time to avoid the combinational clock having errors, because some of the data is late and all this. So they all want to start at the same time. Because they want to start at the same time, they have to grow to a flip-flop. Okay, so this the flip-flop is known as the register. Okay, so in your project, you will also have to put a flip-flop for your circuits after you put in the combinational logic cloud to make sure that the circuits will all start at the same time. Okay, so what is the scan? The scan register is actually a multiplexer here. They add a multiplexer in front of the flip-flop. So they allow the circuit to bypass the flip-flop. So for example here, you can see that one method it goes through directly to the flop, and one way it bypasses the flop and goes directly to the combinational logic cloud. So this is because sometimes the error might occur because of your flip-flop. So you want to be able to bypass the flip-flop. So the scan in registers are actually to bypass the flip-flop to check if the flip-flops has errors. Okay, so in the normal mode, the flip-flop behaves as usual. It means that the combinational logic cloud will get the data from the flip-flop. In the scan mode, the flip-flop behave as a shift register. So it means that the data will not go through the flop, it will go directly from the input to the logic cloud. The contents of the flops can be scanned out and new values can be scanned in. Okay, so this is for today. The topics for the test, design for test, and then next week we will continue more for the topic of critical path